Hello. Let me do the derivatives of these basic functions by using the definition of a derivative. Well, this is a basic knowledge of calculus. It's nice to know that all the details. Okay, let me do one by one. So this is a constant function. The definition of a derivative is this, right? Y f of x dy dx is the limit f of x plus h minus f of x over h as a limit h approaches to 0. So the derivative is a kind of a rate of changes momentarily at a certain moment. Okay, let me do one by one. First is a constant function. F of x, and you can see clearly, f of x equals c. Now, using definition of a derivative, so dy y equals to f of x, dy dx is equal to the limit as h goes to 0, f of x plus h minus f of x over h. So this is the definition of a derivative. This function is equal to c, right? Limit h goes to 0 because a constant function for any value of x is a c. So this is also c, this is h. So this is equal to 0. All right, that's easy. Is constant, the derivative equal to 0. Now, next one is x. While f of x equal to x, then the dy dx, the derivative of y with respect to x, is the limit h goes to 0. Well, let me omit writing the definition. So f of x plus h, because this is a constant function, not constant. This is a identical function. So whatever the value you're given, the function value is equal to the same value. So when you give x plus h, this is also equal to x plus h minus x over h. So x cancel out and h becomes 1, so the result is equal to 1. So this function, the derivative equal to 1. Now the power function y is equal to f of x equal to x to the power of r. R is okay. X is say positive, right? X is not equal to 0. Now R could be any number. R could be integer, real number, and rational, even complex numbers. Okay, let's find the derivative of this. Now, we need a binomial formula. Well, you must know something to do something else, right? When we want to prove the derivative of a power function, we must know this binomial expansion. X plus y h to the power of r is equal to this formula, and when you expand, that is the expansion of a binomial, and x, y are the real numbers, and r is a complex number. I hope you're familiar with this binomial expansion. Now, then Let me do step by step. So given that y is equal to x to the r. Okay, this is a function. Then we want to find dy dx. According to the definition, that is limit h goes to 0 and f of x plus h to the power of r minus f of x over h. Okay. Now then, this is equal to the limit h approaches to 0, and using this, right? Using this is the way, f of x plus h minus f of x, and this is x plus h to the power of r minus f of x over h. Okay. Then we expand it by the binomial formula. This expansion is equal to x to the r plus r times x to the r minus 1 times h, right? Yeah. Plus 2 factorial upon r minus 1 over times x to the power r minus 2 h squared. And next term is this, right? This is 3 factorial and r minus 1, r minus 2, x to the power minus 3 h cubed. And more to come, right? There's more. And over h. Okay. Then this is the limit. H goes to 0. This is h. This is xr. Now the rest of term all have h. So h is a common factor. You have x to the power r minus 1 plus 2 factorial r minus 1 to the power x minus r minus 2 h plus every term has h, right? And the last term, I forget this one, the last term is f of x. F of x is x minus r, so minus x to the power of r. Now, also I have missing r here, right? Sorry, so much details here. Okay, this is r here, right? So now, this cancel with that, and h cancel with h. As h goes to 0, all the terms disappeared. Only one left over, so that is r times xr minus 1's power. So that is the formula that's the result for this function, right? For this function. Okay, so this derivative is equal to r times x r minus 1. That is a very familiar formula for the power function. Now, next one, this actually you can use this formula, right? R equal -1, you get it. But Because this is a frequently used function, I consider it as a independent function. If not use the formula for this one. So we consider this is a useful function. Let's derive this one. So f of x equal to 1 over x. We want to find the dy dx, right? This is equal to the limit as x goes to 0 over h. F of x plus this is x plus h, that is f of x plus h minus f of x. So this one is equal to the limit h approaches to 0. So you can see clearly, okay, this is the common factor x. This is x minus h, right, over h. This is simple algebra. And this is equal to the limit h approaches to 0. Now x cancel out. Negative x cancel with h equal negative 1. As x approaches to 0, this is x squared, right? So that is the result. So this is the result of a derivative 1 over x. Now and then also f of x equal to root x. Okay, you can use formula to find this, but this is a frequently used function. I consider it a separate useful function. Let's derive the derivative. Dy dx is equal to the limit h approaches to 0. F of x plus h. So this is x plus h minus over h. Now this is equal to, all right, the numerator is 0. This is also, the denominator is also 0. Right? We have to do something to. So something is this. We multiply the conjugate of x plus h minus square root h multiplied by x plus h minus plus root x, and h times x plus h plus x square root x. And this is equal to the limit h goes to 0. Now this becomes x plus h minus x, right? And this is h, x plus h plus x. Now x cancel with x, and left h cancel with this h. As x approaches to 0, this is equal to 1 over 2 square root x. So that is the derivative of root x. Okay. Good. Now, e to the x. F of x equal to e to x. All right. This is y, right? Now dy dx is equal to the limit h approaches to 0, h, and this is f of x plus h. This is e to the power of x plus h, right? Minus e to the power of x. Okay. Very good. Now, this is equal to the limit h approaches to 0, h, you have a common factor, right? E to, and this is equal to e to the power of h minus 1. Okay. Now what to do next? Then this is nothing to do with h, right? So we are looking for this limit. Of course, you cannot use L'Hopital's rule. You cannot use derivative to prove derivatives. You have to use something else. Okay, this. What to do? This is equal to the limit h goes to 0, e to the x. Now, you know the definition of e. What's the definition of e? Definition of e is this, right? E is equal to the limit. Well, is 1 plus a number, right? Which is approaching to 0. This approaching to 0. Now, I'm not using letters. I just use symbol. It could be any quantity which is equal to 0 and over 1 over that star, right? So this is E. This is the definition of E. Now we apply where is E? I lost my, let me do it again, okay. I lost it. Let me do it quickly again, okay. Y equal to f of x equal to e of x, e to the power x, and we're looking for dy dx. This is equal to the limit h approaching to 0 and e to the power h plus x minus e to the power of x over h. Now this is equal to the limit h approaches to 0, h and e to the power of x is a common factor, is e to the power of h minus 1. All right, now I just did the definition of e, right? So this is e to the x. This e is 1 plus h to the power of 1, and that is e. This is e. And to the power h again. This x, this h is this h. This e is this. Minus 1, right? Over h. Right? This is equal to the limit h approaches to 0, h e to the x, and this is a 1, right? 1 over h times h is a 1, so left over 1 plus h minus 1, and cancel with 1, cancel with h, the result is e to the power of x. Well, okay, so this function, the derivative is e to the x. Next one is log x, y equal to f of x equal to log x, right? X is a positive. Now, what to do? Okay, by using the definition of a derivative, right? dy dx is equal to the limit h approaches to 0, h, this is f of x plus h, so this is x plus h minus log x, right? Simply definition. Now this is equal to the limit and I use the derivative, the property of logarithm, right? This is equal to x plus h over x. That's correct. This is equal to the limit h approaches to 0, And this is equal to log 1 plus h over x, right? Yes. And this is h. And I multiply by x here times x here. Because x is not 0, it's allowed. Then this one is the limit h goes to 0. This is x here. X over h. X over h could be written here. So log 1 plus h over x. And x over h could be written here, right? By property of log, x over h could be written here. And this is as x approaches to 0. What is the definition? This is definition of E. Limit something goes to 0, 1 plus something over 1 over something. That is E. Now here, this is going to 0. This is a 1 over going to 0, right? This is a 1 over h over x. So this is nothing but a E. So this is equal to no more h, right? Log e over x. Because this is E. This is E. E is this. Yeah, all right, E is this. So log of E is 1, right? So 1 of x. So that is the result. So that is a function. My next one, log a to the x. Well, of course, we can find this derivative by using this way, by implicit differentiation, right? But we just supposed to consider it as a separate, individual function, and we find the derivative of that function by using the definition. Okay, so let's see. This is maybe a little tricky. All right, this is y equal to f of x is equal to a to the power of x. So a is positive. Now, how do we start? Dy dx is equal to the limit h approaches to 0, a to the power of x plus h minus a to the power of x over h. And then this is equal to the limit h goes to 0. There's a common factor, right? A to the power of x brackets a to the power of h minus 1. Yeah, over h. And then what? This is nothing to do with h, therefore this could be out. Now we found this limit. This limit. This is approaching to 0, so this is 0, this is 0. Of course, you cannot use L'Hopital's rule, right? L'Hopital's rule needs a derivative. Now we find a derivative by definition. We cannot use derivative to do. So what to do? Okay. We consider this limit. We consider this limit h goes to 0, h a to the as a what? As a say, can I use h? Can I use x, right? Say this alpha. So we're looking for alpha because this is nothing to do with h. Now, how do you find alpha? Let's take the power over e to the alpha is equal to e to the power of a to the h minus 1 over h. Right? Yeah. Okay. This is rather tricky. This is good to. This is equal to E. What's the E? Let's back to the E is this. E is this. So this is star. The reason I'm using star, I mean, it could be anything. Could be anything as long as it goes to 0. And this is 1 over E, 1 over star. Anything satisfy this is E. So E, I'm writing this way. E is equal to, because h goes to 0, right? The limit h goes to 0. This E is 1 plus 1 plus a to the power of h minus 1 to the ah goes to 1. That's E. Look, E is this. This E is equal to this. Why? Because this one goes to 0. This is 1 over this. This is my star. A to the power of h minus 1 is my star. This is 1 over star. And to the power, now here I didn't finish yet. This is a to the power of h minus 1 over h. Alright? This is E. This is E. This is star, right? So this one is equal to the limit h goes to 0. One cancel out. One cancel out. This is a to the h, right? Power h. And this one cancel out is a 1 over h. See, this cancel with that, 1 over h. So this is equal to a. So what's A? A is e to the alpha. E to the alpha, right? E to the alpha is A. So what's alpha? Alpha is, therefore alpha is log A, right? Alpha is log A. Now the derivative, therefore the derivative of a to the power x, the derivative of this function is equal to ax times alpha, right? Alpha is log A. So that is the result. Well, tricky. Okay. All right. So we have done all the algebraic functions. Then we do the trig functions. Now, I select these, right? The rest is similar. You can do by yourself, right? I just do sine, cosine, tangent, secant, and arcsine, arctangent. Now, let me get more papers. Okay. First, the sign. To do these trig functions, we need some formula. Well, we must know something to do something else, right? You cannot do something knowing nothing, right? So these are basic formulas we needed to find the derivatives. First is this: the limit. This limit is 0. This limit. So this is 0. Excuse me. This is equal to 1. Yeah. Now this limit equal to 1. This limit is equal to 0, and the arcsine x minus arcsine y is equal to this one, right? Well, we have to use the formula to get the derivative, and this arctangent or x minus arctangent y equal to this. All right, now we can start. We are looking for derivative. These are derivatives. So one by one. Sine first. Y equal to f of x equal to sine x. We try to find the derivative of y with respect to x. Dy dx is equal to the limit h goes to 0. H here, the sine x plus h minus sine x. Right? That is the definition of derivative. And this is equal to the limit h goes to 0. And this is a trig formula, trig identity. This is sine x cosine h plus sine h cosine x minus sine x. That's straightforward. This is equal to the limit h goes to 0, h. And this one with that one, you have a common factor. So sine x, you have a 1 minus cos h, right? And plus sine h times cosine x. And this, you have a two fractions, right? This over this plus this over that. And this is equal to the limit h goes to 0. Now, as I said before, we know we need these formulas, right? This limit is 0. So 1 minus cos h over h as h goes to 0 is 0. So this one is 0. And sine h over h as h goes to 0 is 1. So the result. So you only need 1. So this is equal to cosine x, right? This over this as h approaches to 0 is 0. Sine h over h as h goes to 0 is 1. Therefore, you get this result. All right, this is done. Then next one is cosine x. Y equal to f of x equal to cosine x. We try to find a dy dx. Dy dx is equal to the limit h approaches to 0 cosine x plus h minus cosine x over h. So this one is equal to the limit h goes to 0. H, the formula for cosine is this cosine x cosine h minus sine x sine h, right? minus cosine x. And then algebraic work is h. This one common factor a cosine x plus cosine h minus 1 minus sine h sine x, right? And as we show this limit, right, equal to approach to 0. So this one is approach to 0. This one is approach to 0 as h approach to 0. This one is approach to 1 as a sine approach to 1. So sorry, as sine approach to 0. This is 1. So you have a negative 1. This is 0. This is negative sine x. So the derivative of cosine is negative sine. Okay. Next one. Now the tangent x. Tangent x. Okay. Y is equal to tangent x. So the derivative dy dx is equal to the limit h goes to 0, h here. This is a tangent x plus h minus tangent x. Yeah. Now is equal to the limit h goes to 0. H here. And by the formula for tangent, this is equal to tangent x plus tangent h over 1 minus tangent x tangent h minus tangent x. I hope you can see clearly. Now this is equal to the limit. Let me write a little bigger. So h approaches to 0. H here. Then this is equal to 1 minus tangent x tangent h. This is equal to tangent x plus tangent h minus. So this minus tangent x, this time this one, right? Plus tangent square x tangent h. Yeah. Simply add these two together. This is equal to the limit h goes to 0. Now here we h. The tangent x cancel with tangent x. And leftover tangent h common factor, right? 1 plus tangent square x over this. 1 minus tangent x tangent h. Well, we have something which is much simpler. Now then what? Then we try to find a limit as h goes to 0. Now this is nothing to do with h. This one goes to 0, so this goes to 0. This is 1. So leftover tangent 1 plus tangent square. Left over the limit h goes to 0. Tangent h over h, right? Because this has nothing to do with the h. This one goes to 0, this is 1 times h. So this is the limit. Now this is 1 plus tangent square x. Now we change this one into sine of cosine, right? This is sine h over h and times cosine h. And we know that this one, as h goes to 0, is a 1. Therefore, this one is equal to 1, right? This is a 1, cosine 0 is a 1. 1 times this, right? That's tangent square x. This is equal to secant square x. So the derivative of tangent is a secant square. Now, of course, you can do cotangent by yourself, right? So this is, we just omitted the cotangent. Now, next one is secant. Next one is secant, right? Now, y is equal to secant x, right? So dy dx is equal to the limit. We use definition, and this is equal to h, and this is secant x plus h minus secant x. All right, what to do? Now, if we change it secant into sine or cosine, it's much familiar, much simpler for us, because we have 6 trig functions, right? Sine and cosine is more familiar to us, like a brother sister, and tangent, cotangent, a little way, I mean cousins. And secant, cosecant is even further, is a distant cousins. So let's change it to sine and cosine, as it might be simpler. So this one is equal to the limit h goes to 0. This is h, so this is 1 over cosine x plus h, right? Minus 1 over cosine x. So now for us, the game is simpler because we are familiar with sine and cosine. And this one is equal to the limit h goes to 0. So this is a common factor, right? This is cosine x plus h and cosine x. So this is a cosine x minus cosine x plus h. Yeah. So far so good. Yeah, this is a common factor. This time this one is this one time this one is that. Okay, now then this is equal to the limit h goes to 0. H cosine x plus h. No. Well, I think this common factor is cosine x plus h. Cosine x plus h. Yeah, that's the way. All right, sorry. X plus h. No, this is okay. This is cosine x. That's the way. Yeah. All right. The common factor is common denominator is cosine x plus h times cosine x. And here this is cosine x minus that x is cosine x cosine h, right? Minus become plus sine x sine h. Yeah. So far, so good. I think, excuse me for this, there's something mistake. This x goes 0. This is okay. H goes to 0, that's cosine x. Because of the cosine square, right? Cosine square x. So this is h. This is a cosine square x. And this common factor, right? cosine x common, 1 minus 1 over minus cosine h. It has to be very careful because sometimes the error comes easily. Sine h. All right. Now we still use this one, right? Sine alpha over alpha approaches to 1, then when alpha is approaches to 0, this one is approaches to 0. So this one, you see, that one is approach to 0. Okay? So the first fraction is 0. Now the second fraction is sine h with h is approaching to 1. So therefore this one is equal to sine x over cosine square x, right? This one over this one as h approaches to 0 is 0. Sine h over h approaches, when h approaches 0 is 1. Therefore end up with this. This one is equal to tangent, right? Tangent times 1 over x times secant. So that is the derivative of secant. Secant derivative is secant times 10. Okay, now we have two more left, arcsine and arctangent. They're maybe not that easy. Of course, we can find the derivative of these two functions by using implicit differentiation. We use sine and tangent. But here, we are using definition. Nothing but definition. No other method but definition. So we have to use definition of a derivative to find the arcsine. Well, let me do it slowly because this is a little tedious. Y is equal to arcsine of x. Now we want to find a dy dx, right? This is equal to the limit x goes to 0. Not x, sorry. h goes to 0, and arcsine x plus h minus arcsine x over h. Well, I have to be very careful, and yes, any little careless thing could be result in a big error. So this is equal to the limit h goes to 0. H. Now we need a formula, right? We need a arcsine formula. Well, we must know something to prove something else, right? So this one becomes arcsine. Now the formula says this times square root of this one. So this was a bracket x plus this one times square root 1 minus x square minus x, this is x, right? X square root 1 minus x plus h square. I hope it's right. Yeah, nothing's wrong. Now, the limit h goes to 0. What to do with this? Now we want to simplify this. I think let's find multiply by conjugate. Okay, multiply this one, x plus h square root 1 minus x square plus x square root 1 minus x plus h square. And on top, also multiply by this one. It's a conjugate, right? So it becomes this square minus this square. This becomes x plus h square times 1 minus x square minus x square times 1 minus x plus h square. Okay, that is. So one story becomes 2 stories. Now a bungalow becomes a cottage. Okay, now over h. This is equal to the limit x. This is over h. This is sine inverse. And you have 2 story, beauty. H approaches to 0. H approaches to 0. This is 1 minus x squared. 1 minus x squared. This is x. So it becomes x square root 1 minus x squared 2. Correct? As h approaches to 0, the denominator becomes this. Now the numerator, let me write h smaller, I have more space, okay? Now, this one, this one times this one is 1 plus h square, right? Minus x square times x plus h square minus x square plus x square 1 x, this one times this one is plus, right? X plus h square. Well, I hope no mistake. It's very easy to yield some kind of error. So this one cancel with that one, right? This one cancel with this one. Left over sine inverse 2x 1 minus x square. And let me write h smaller. There's more space. All right, this. Okay, now this one is x square plus 2xh plus h square. Cancel with that one, right? This is the case. So you have a 2xh plus h square. That's right. Okay, do you see it? Now this one and that one is cancelled out. When you expand this one, minus x squared, you have this. Now 2x cancel out. H sine inverse so this is h 2x plus h. This is 2x 1 minus x squared. This is h, right? Yeah, as h approaches to 0, don't you think this is approaching to 0? So is this approaching to 0? That means if this is alpha, right? This, well, this means as h approaches to 0, the sine this arcsine no, this is over h. This one, as h equal to 0, this is 2x. This whole thing goes to 0. That means this one, goes to 0. This, let me say this is alpha, right? This alpha goes to 0, and h goes to 0 too. That means, now, I have to explain something here. Something important, I'll write it big, okay? We know that sine alpha, the limit, alpha goes to 0, this is equal to 1, right? Which means that sine alpha is equal to alpha as alpha goes to 0. When this angle is very small, then the sine of this angle is equal to that angle. This could be understood. I'll repeat again. The limit alpha goes to 0, sine alpha over alpha is 1, which means that when alpha is approaching to 0, sine alpha is alpha. And if you write the arcsine, okay, that means arcsine alpha is alpha. So as alpha goes to 0, this is this. Arcsine is. So we know that this goes to 0. Do you understand? This is a little difficult to explain. This one is approaching to 0. Therefore, this one is equal to arcsine this. So this means that as h approaches to 0, arcsine this is equal to this. Understand? I'll repeat again. As alpha goes to 0, sine alpha is equal to alpha, or arcsine alpha is alpha. Therefore, when this one approaches to 0, arcsine this is equal to this. Okay? So this one is equal to the limit h goes to 0, h here, and we can forget arcsine. This is h, 2x plus h over 2x square root 1 minus x square. H cancel out. Okay. H equals to 0, 2x cancel out is equal to 1 over. Oh, bingo. Okay, we do the last one, arctangent. Now arctangent, let me use the big marking pen. So y equal to arctangent x. Yeah, this looks better. And the dy dx is equal to the limit h goes to 0, and arctangent x plus h minus arctangent x over h. This one is equal to the limit h goes to 0, and we use the formula, right? We must have something to do something else. So this is the formula. So then we have a arctangent and this plus minus this one is x plus h minus x, and 1 minus x plus h times x over h, not x. Okay, so far so good. Now then we cancel with h. This is equal to the limit this is h, this is arctangent, this is x, no, sorry, h, and one, I copied wrong formula. See, this is plus, right? So this is plus 1 plus x plus h times x. Now this one is limit h goes to 0, arctangent h 1 plus, as h goes to 0, this whole thing goes to 0. This arctangent goes to 0. Arctangent goes to, okay, now same story, repeat again. Let me see where the paper I used before. See, I couldn't find it. So here. This, well, I'll repeat it many times, right? So now, tangent alpha is equal to sine alpha over cosine alpha. As alpha go to 0, don't you think tangent alpha over alpha goes to 1, right? Because this over alpha is going to 1, because sine alpha over alpha is 1. So which means that tangent alpha is equal to alpha when alpha is very small. See, I just repeat the last story again. So when alpha is very small, tangent alpha is alpha. So when this one goes to 0, see, this one goes to 0, right? The whole thing goes to 0. Therefore, this one is equal to the limit h goes to 0, h 1 plus tangent square. So this one is equal to 1 over 1 plus tangent square. So that is the result, because this h can cancel out. Here I use same argument that when the angle is very small, arctangent something is something. Arcsine something is something. In other words, when the angle is very small, sine alpha is equal to alpha. Arcsine alpha is equal to alpha. Tangent alpha is to alpha, and so is arctangent alpha is alpha. Because the angle argument, when the angle is very small, tangent sine, there's no difference. Well, we can see that from unicircle, right? This is a unicircle, and this is alpha, right? This is alpha, and this is sine alpha. This is tangent alpha. When alpha is approaching to zero, this is approaching to zero. This is approaching to zero, and when angle is very small, there's no difference. Because the unicircle, right? This angle is equal to this length, and the angle is very small. They're almost the same. I don't know. It's but anyhow, I proved all these basic formulas. We get the derivative of these functions by using derivatives. And for any student, for anybody who studied calculus, you better know them. Okay, better know those things by definition. This is a kind of a basic training, and I hope you can go through by yourself, right? Okay, thank you for your watching.